It's my pleasure today to bring you another episode of Linear Algebra, Self-Study, Mastery. What did we learn yesterday? Well, we read a little about the authors, two PhDs in mathematics. This book is very highly praised and awarded. It has a large focus on pedagogical techniques and philosophy. Calculus is not required for prerequisite for this linear algebra text, but there are some optional exercises that do require calculus. So I may attempt those, may not. It's been years since I've been in calculus, and I'll be honest, I didn't learn it that well the first time. 5 years ago now. Anyway, what else? There's online portions. There's like online exercises and things to do with the computer, which are available through a website that I have a link to now. Yeah. Okay. What else do we read about? New to this edition, which we kind of just skimmed through, not super important for us. There's an alternative edition to this textbook, and that has a 10th chapter. This one only has 9 chapters. That one has a 10th chapter, full of applications. Though this does have application exercises. That a whole chapter 10 is dedicated to applications. So unfortunate that I read that at the beginning, but I'm going to continue pushing on with this textbook. It's in loosely form, but it's a textbook. I could see myself getting that textbook after completing this to do all the applications. I think that would be a good use of time and money. However, we'll continue with this one for now. What are some of the key teaching and pedagogical structurings to this textbook? Well, and philosophy. So building to abstraction slowly and building up to abstraction, because some people have a hard time going from, they said, from Euler vector spaces to general vector spaces, so they bridge that gap more thoroughly. What else do we read about? We read about that the exercises in this book, we read a section about that. They're divided into proof based problems, true and false based problems, and technological exercises. The proof based problems, there's an appendix to read, which I'll read after the preface. The true false require some sort of justification, so it's not just guessing. The technological exercises, not sure what the point was on that one. What am I missing? What's some more pedagogical stuff? I don't know. See what I'm forgetting. Smooth transition. Okay, mathematical precision. So let me just scan them. Okay. So a few things I forgot were, so some more of the pedagogical stuff. Mathematical precision. They're as mathematically precise as possible while still being available to a diverse audience, which is another point. This text is available to basically everybody that wants to take linear algebra at an undergraduate level. They also have historical notes to give historical context to the ideas within that are taught in this book. They also, what was the last thing on the pedagogical things? Interrelationship between ideas. So they don't want to present a linear algebra as a bunch of independent ideas. They want to show the interrelatedness, how they're one collection of related ideas. Okay, and then supplemental material at the end of each chapter. There's a supplemental section just all with exercises mixed up from the previous chapter. Okay, now we're caught up to speed. Gosh. Oh. All right, before I get into the new reading for today, I just remembered we're going to have Anki. We definitely have some Anki flashcards, or one Anki flashcard to get through. I forgot to do. Here we go. Boom. Okay. Oh, look at that camera angle. All right. What are the 9 chapters in elementary linear algebra? Here we go. Systems of linear equations and matrices, determinants, Euler vector spaces, general vector spaces, eigenvalues and eigenvectors, product spaces, something inner product spaces, display, translation, no, but translations and quadratic forms. No, it's something in quadratic forms. Translations in quadratic forms, no. Dang it. And then it's general linear translations and normal, dang it, thesis, normal sequence, normal, diagonalizations and quadratic forms, general linear translations, normal numerical methods. Damn it, bro. Linear systems of linear equations and matrices, determinants, Euler vector spaces, general vector spaces, eigenvalues and eigenvectors, inner product spaces, diagonalization and quadratic forms, general linear transformations, numerical methods. All right, we're gonna have to see it again tomorrow. I was literally 2 words away. Whatever. All right. Now I'm going to read. Some, and then I will come back and recall. All right, I just read the supplemental stuff for students, supplemental resources for students. A lot of data files, MATLAB stuff. But the key stuff that I got is there's a set of videos on the website that are called How to Read and Do Proofs. So I'll probably check those out at some point. Also, there's an app I downloaded. It's a really like poorly designed app, but it's got flashcards for each section. So maybe I'll take the flashcards from that app and put them in Anki. Apparently it's to test your understanding of all fundamental concepts of this text. So that's pretty solid stuff, right? All right. Anything else? Okay, we're good. There's stuff at the end of the text, like answers for most odd questions. All right, now I'm going to read supplemental materials for instructors, a guide for instructors, reviewers, and special contributions. I'm just going to finish out the preface right now. Let's do it. All right, nothing too much of note in there. Finish the preface. That's it. Now I've got, at the end of this, I said, should I ask ChatGPT if I should read Appendix B before starting Chapter 1? I'd really like to just get started with Chapter 1, to be honest. I'd like to just jump in and start learning stuff straight from the book, but I guess proof stuff is learning stuff. So let me go ahead and ask ChatGPT, and I'll let you know the response. All right, ChatGPT is recommended to read both appendices. So great stuff. That's fine, I guess. We'll flip back to there. Here we are. Appendix A, working with proofs. Only 4 pages. Okay. I'll go ahead and read just the first paragraph and then recall it because we've only got 2 minutes left. So then we'll call that a day. All right, so 3 points from that first paragraph that I got. First off, linear algebra is more than just a collection of problem-solving techniques, unlike some other earlier, more elementary math classes. The authors say, even if you are able to solve all the problems in this book, you will still be short of mastery. Why is that? Well, because the innovative application of linear algebra requires an understanding of its proofs and theorems. And so this section sets up what are proofs, how do you do proofs, how do you understand them, how do you read them, etc. So nice. We are now kind of in the book. We made it out of the preface today. We finished like the intro, or like kind of the intro, the table of contents, the preface, about the authors, like all the prelude. Now we're at the stuff at the very back of the book, appendices A and B, and then we will be into chapter 1. But at this point, we're learning actually really valuable stuff. This stuff is foundational. What is a proof? I think a proof is like a logical argument. Or is that a theorem? Yeah, a proof is a logical argument, right? That shows the validity of a conclusion based on assumed truths and valid logic. But I think so. We'll see how this section goes. I'll talk to you guys later.